Earlier that night, two people were sucked into a vortex.
How many people were sucked into the vortex, scientist?
I'm not sure, but we can figure out how many people were in the room to begin with.
But how?
Come with me, I can show you. There is a radar placed at the doorway, as we can see in this video, that can count the number of people entering and exiting the room. We see how the counters for the people walking in and the people inside the room increases in this scenario where this person walks into the room. In this next scenario, the same person walks out of the room. In this case, we see that the number of people walking out of the room has increased by 1, while the total number of people inside the room has become 0 because the person walked in and then walked out of the room. This novel technology is used to quantify pedestrian traffic traversing through a doorway.
This is great, scientist. Thank you. We can use this to figure out how many people were sucked into the vortex. And that brings us to our main motivation. The main motivation for our project is energy conservation, but it can also be used in other applicable real life situations like fire safety and making sure we're tracking how many people are in a building that may be on fire, and crowd control in large outdoor situations. As you can see, the energy consumption per energy need for a building um, results in these different percentages, with lighting being the second highest percentage of energy consumption. However, it is known that occupancy tracking systems can lead to an average reduction in energy consumption of up to 20%, which is the main purpose for our solution. Our problem statement states that tracking centroids generated from 3D point clouds from radar will quantify pedestrian traffic traversing through a doorway. As we can see, each centroid corresponds to a human subject that we will then be tracking.
In our high-level solution, we see in the image on the left that as soon as the person enters the detection zone, we can identify these centroids and cluster the points as a human subject. The image on the right shows us that when we first get our signal, we will denoise it, and then using the k-means clustering algorithm as well as the Kalman filter, we'll be able to track the person's location to reach our expected results, which is to increment the count of people going in either direction based on the range profile and point clouds in the detection zone.
But what are some potential challenges of our solution, you may ask? Well, state-of-the-art systems typically handle the challenge of tracking multiple individuals going through a doorway with multi-sensor fusion and clutter filtering. However, this can lead to misalignment and blockage of the radar and can introduce uncertainties. So we will not be addressing this in our solution, but tune in on Tuesday, December 5th to learn more about our project. Thank you.